They're my electrons. You can't have them. My electrons. There are a few topics in organic chemistry that I call the non-negotiables. These are the things you have to understand, you have to master, you have to know cold if you want to succeed in organic chemistry. Without these non-negotiables, success is going to be really hard to find. One of them is electronegativity and polar bonds. Electronegativity we can think of as an element's selfishness towards electrons. They're my electrons. You can't have them. My electrons. The more selfish an element is towards those electrons, the more electronegative that element is. Electronegativity increases up towards the top right of the periodic table. So it increases bottom to top, it increases left to right towards fluorine in the periodic table. In fact, fluorine is the most electronegative element on the periodic table. You have to know this. Everything goes left to right, everything goes bottom to top. Fluorine is the most electronegative element on the periodic table, non-negotiable. The corollary to this then is polar bonds. Polar bonds are bonds shared between two elements of different electronegativities. And when that happens, the electrons are distributed unequally between those two elements. For instance, if we have a bond between an oxygen atom and a hydrogen atom, oxygen makes two bonds, so there's something else going on over here, but let's focus on the OH bond. This bond is polarized. It is a polar bond between oxygen and hydrogen because oxygen and hydrogen have very different electronegativities. Now, you don't actually need to know what the specific electronegativity is for oxygen and for hydrogen. It doesn't even really matter. Oxygen's up toward the right side, hydrogen is up toward the left side. So oxygen is more electronegative than hydrogen. That means the bond is polarized, and it is polarized toward the oxygen. We use this symbol to show a polar bond. The little cross over the end of the line here means that this side is the positive side, and it's pointing toward the negative side. What does that mean? It means that oxygen is pulling more electron density towards itself. Because it is electronegative, it's pulling the electron density towards itself and away from that hydrogen. That means that the oxygen has a partial negative charge. It doesn't have a full negative charge. It doesn't have a full extra electron, but it has more electron density than we would otherwise expect. And it means that hydrogen has a partial positive charge. It doesn't have a full positive charge, but it has fewer electron density, less electron density than we would otherwise expect. This is a polar bond, polarized towards oxygen. Oxygen is partial negative, hydrogen is partial positive, all because oxygen is more electronegative than hydrogen. This will have huge implications for the reactivity of this molecule when we do reactions later on. Knowing that oxygen is partial negative is critical. Knowing that hydrogen is partial positive is critical. Knowing that this bond is polar is critical. It's non-negotiable. We have to be able to look at a molecule like this and see the polar bonds immediately without thinking about it. It's that important. As another example, if we have a carbon-chlorine bond, carbon makes 4 bonds, so there's 3 other things going on with the rest of this molecule. It doesn't matter what they are. A carbon-chlorine bond is also a polarized bond. It's polarized due to the fact of the electronegativity difference between the elements and the fact that chlorine is lower down on the periodic table, so it's larger, it's more polarizable. That's a bit beyond the scope of what we're talking about right now, but this is a polarized bond. It is polarized towards chlorine, away from carbon. Carbon's partial positive, chlorine is partial negative. Carbon has fewer electrons than we'd expect, chlorine has more electrons than we'd expect. Carbon is missing some electrons, chlorine has a little bit of extra electron density than we would otherwise expect. This is a polar bond, very important. Knowing that this carbon is partial positive, that it lacks electron density, is going to be so important for predicting reactivity later on. You have to know polarizability. You have to know that the periodic table is electronegative up toward the fluorine. Fluorine is the most electronegative. That a bond between two elements of different electronegativity is going to cause a polar bond, polarized towards the more electronegative element. The more electronegative element is partial negative, the less electronegative element is partial positive. You have to know it. Non-negotiable.
Thanks for joining us today, ninjas. Be sure to watch these other videos to level up your ninja training even more. As always, don't forget to like and subscribe.